A town ordinance defines an adult tree as having a diameter greater than 10 inches and a sapling as having a diameter less than 10 inches. The ordinance requires that on a new building project, 2 new trees are planted for each adult tree felled, and 6 new trees are planted for each sapling felled. Last year, there were 167 trees felled, and the community planted 742 replacement trees. How many of each type of tree were felled? We're going to let A equal the number of adult trees felled and T equal the number of sapling trees felled. So that means that A plus T equals 167. This equation represents the total number of adult trees A and sapling trees T felled with a sum of 167. Because remember, it said that 167 trees were felled. Some of them were adults, some of them were saplings. And then we're going to use the equation 2A plus 6T equals 742 to represent the number of adult trees A and sapling trees T that were replaced. The solution of the system of equations represents the option that meets both of the constraints. The first equation can easily be solved for A or T. Select a method to solve the system of equations. A plus T equals 167. 2A plus 6T equals 742. We're going to look at solving for A first, and then we'll look at solving for T. This video is going to be a little bit longer since we're going to go through both methods. When solving for A first, we get A equals 167 minus T, right? We just subtracted T from both sides, moved it over. So we're going to take 167 minus T and substitute it into our second equation. So it becomes 2 times the quantity 167 minus T plus 6T equals 742. Now, in case you're wondering, because I forgot to mention it earlier, the 2 and the 6 have to do with the ordinance saying that, where's it at? 2 new trees planted for each adult tree and 6 new trees for each sapling. So when they're replacing the trees, they're not just putting in 1 adult and 1 sapling, they're putting in 2 adults or they're putting in 6 saplings. Okay, so we distribute our 2 and we get 334 minus 2T plus 6T equals 742. Combining our like terms, we get 4T plus 334 equals 742. Subtracting 334 from each side, we get 4T equals 408. And dividing by 4 on each side, we get T equals 102. What this means is that, oops, I clicked too early, is that there were 102 saplings planted. So now we're going to figure out how many adult trees were planted. So we take our 102 and put it back into that first equation because it's going to be the easiest to work with. So 167 minus 102 tells us that there were 65 adult trees planted. So we have 65 for A, 102 for T, or 65 for X, 102 for Y. And that tells us that at the end of this project, 65 adult trees were planted and 102 saplings. Because only whole numbers can be used for trees, this is a viable solution, right? You're not going to fell half a sapling or whatever. Let's look at it as if we were solving for T. Very similar, we're going to subtract A from both sides. So instead of 167 minus T, we have 167 minus A. We plug that in. So this time we get 2A plus 6 times the quantity. 167 minus A equals 742. Distributing our 6, that gives us 2A plus 1002 minus 6A equals 742. Combining our like terms, we get negative 4A plus 1002 equals 742. Subtracting 1002 from each side, we get negative 4A equals negative 260 and dividing by negative 4 on each side, we get a equals 65, the same number that we got in our solution of the first method. Plugging 65 back in, 167 minus 65 is t equals 102, so we end up with the exact same answer using both methods. Using systems of equations to solve real-world problems generally requires assuming that the problem actually has a solution. It is a good idea to graph the lines first to see if a solution exists before going through the steps to solve for each variable. The only downfall to doing that is sometimes the equations are hard to graph because the numbers are so big. But it is a good idea if it's a really quick, simple equation to just jot it down on a graph really quick and see if it does in fact have a solution before going through all of the work of solving for them.